Hello Miss, today we will be showing you how to perform math operations, as well as how to solve some matrix maths using Microsoft Excel. First we move the cursor to the area where we want to display the result. Then we press equal on the keyboard, drag over all the data in matrix A, press the plus sign, drag over all the data in matrix B, and finally press enter. With the subtraction of two matrices, we also repeat the same steps as the addition one. Matrix multiplication has a condition. The number of columns in matrix A must be equal to the number of rows in matrix B. We also move the cursor to the area where we want to display the result. Press equal on the keyboard, enter the mult function, open parenthesis, drag over all the data in matrix A, type a comma to continue the operation, drag over all the data in the matrix B, close parenthesis, and then press enter. For a matrix to have an inverse, that matrix must be a square matrix, and its determinant must be non-zero. We continue to move the cursor to the area that we want to display the result, press equal on the keyboard to prepare the math operation, then enter the minverse function, open parentheses, drag over all the data in matrix A, close parentheses, and press enter. We have the following system of equations. To find the value of variables, we will represent the system in the form of a matrix, which is written as follows, where A is the coefficient matrix and B is the constant matrix. The system of linear equations has the form AX equals B. To find x, we multiply the inverse of the coefficient matrix with the constant matrix. We first calculate the inverse matrix of A, or matrix A to the power -1, using the function minverse. Select the area that we want to display the results, enter the mult function, drag over all the data in the matrix and press enter. Next, we will discuss about how we find the equilibrium point of supply and demand. Suppose the market consists of 4 products, goods 1, 2, 3, and 4 with the following supply and demand functions. Find the equilibrium point of supply and demand. From the equilibrium point we have QS1 equals QD1, QS2 equals QD2, QS3 equals QD3, QS4 equals QD4. We will replace the supply and demand functions for each QS, QD, and convert the functions into a system of equations. From the final system of equations in this slide, we rewrite this in form of a matrix as follows. First, we will apply Cramer's rule, create a matrix A1, A2, A3, and A4 by replacing the constant terms of the equations into columns 1, 2, 3, and 4. Then we calculate the determinant of the matrices A, A1, A2, A3, and A4 with them to term function. Select the area where you want to display the results and enter the function. We have the following variables calculation formula. With AJ is the matrix obtained from A by replacing the jth column with the constant terms of the equations. By applying the formula, we find the solution of the system by dividing the determinant of AJ by the determinant of A. Press enter to get the results. This is the equilibrium point we need to find.
One of the models we would like to talk about is the input-output model.
Consider an input-output model with 4 fields: agriculture, manufacturing, power, and oil. Assume that the input requirements are given by the following table. Know that the final demand is B, 500, 600, 750, 530. Find the total demand X. To calculate X, which is the aggregate demand matrix, we have the formula. With A is the technical coefficient matrix. X is the total demand matrix. B is the final demand matrix. I minus A is a Leontief matrix. I minus A all powers -1 is the total cost coefficient matrix. To find the I minus A matrix, we subtract the matrix of units I from the matrix of technical coefficients A. Then we will find the inverse matrix of I minus A matrix by using the minverse function. Finally, applying the formula above, we use the mult function to multiply the total cost coefficient matrix with the final demand matrix. Press enter to get the results. This is the total demand X we need to find. About the ISLM model.
Consider an ISLM model with elements given below.
C equals 0.6 y plus 35. I equals 65 minus r. G equals 70. L equals 5y minus 50r. M equals 1,500. Find the level of national income y and the equilibrium interest rate r. First, we have the IS and LM equation as follows. From 1 and 2 we set up a system of equations. We will convert the above system of equations into a matrix, and then continue to perform the calculation on Microsoft Excel. Next we will calculate the determinant of the A1 and A2 matrices with them determ function. To find the variable values, which is the system of national income, and the equilibrium interest rate, we take the determinant of A1 and A2 and divide to the determinant of A. And our final answer will be y equals 400,000 billion VND, and r equals 10%.
We hope you enjoy this small video. Thank you for watching and have a good day.